Okay. There we go. Anybody needs a pencil? I got plenty back here. All right, come on back. I got a bunch behind where I'm sitting. Yeah, come on up. Come grab them. All right, so today is October 18th. And we're just going to start off with a quick reminder on what slope-intercept form is. And slope-intercept form says y equals mx plus b.
Did you look at the black? I don't want that.
And yesterday's lesson was all about m. What does m stand for? Slope. And what does b stand for?
X and y-intercept.
That one, yeah, the y-intercept. The easiest way to remember slope-intercept form is that it tells you in the name of the form the two parts of the equation that you get in that form, slope and the y-intercept. That's why it's called slope-intercept form, because those are the two things that are in the equation. Yeah. So first thing we need to do on each of these problems is figure out the slope and then figure out the y-intercept, and then we're going to go ahead and write the equation in slope-intercept form. So the only thing that you need to do with slope-intercept form is you're going to replace m with the slope, the number for the slope, which we did yesterday, and then you're going to replace b with the number for the y-intercept, which is actually really easy to see when you're looking at a graph. So here we go. I'm going to start with m equals here, and then I'm going to write b equals here, and then we're going to write the answer to y equals mx plus b underneath it once we have m and b. So I want you to find the slope of this line just like we did yesterday. Remember, you're looking left to right, and then you can count up for this one and then over. Up, and then, yeah, you're looking at it from the left to the right. So you're going to go up and then over because we need rise over run for the slope.
-3.
Wait, what? For number one?
Oh, no, that's a minor.
Okay. 4 over 2.
4 over 2.
Rise over run would be 4 over 2. Up 4 over 2. What does that reduce to? 2. Good. There you go. Thank you. So the slope is 4 over 2, which just equals 2. So we have a slope of 2. And after that, I think you already said it, Ralph. What was the y-intercept? -3. Why is that? Ralph, why is the y-intercept -3?
Because the first goes to the y-axis.
Yeah, so you got your x-axis going left and right, your y-axis is up and down. The point where the line crosses the y-axis is the y-intercept. So find the dot that's on the y-axis. This one is 3 down from the middle, which means it's at -3. So b equals -3. So all we need to do now, I'm going to write y equals, I'm going to leave the blank for m, I'll have x and then plus. I'll say it again. So the y-intercept is where the line crosses over the y-axis. And so you're just going to look for the dot that's on the y-axis. And so here, it's 3 below the middle of the graph. So it's -3. So all we need to do now is take the value of m, which is 2, and substitute it in for m. And we're going to take the value of b, which is -3, and we're going to substitute that in for b. And we'll be able to write our answer and we'll be done. So let's see. So the answer here is going to be y equals 2x. You could write plus -3, or you could just write -3.
Wow.
And I'm going to write -3. So y equals 2x -3. Hopefully this looks familiar, because this is definitely stuff that you did last year. A lot of last year. There was lots of slope intercepts in Algebra 1. All right, we're going to do number 2 together. Shh, listen up. Number 2 as a class, and then I'm going to have you do 3 and 4 on your own. Here we go. Problem number 2. Our slope going from left to right. This time, do we have a positive slope or a negative slope?
Oh, so that's our.
Yeah, the answer is right down here. Positive or negative slope on number 2? Number one was positive. This one goes down though.
Goes down.
So from left to right, always look from left to right. So from left to right, it's going in a downward direction. Yeah. So always look from left to right. And then we're going to count down and then over. How far down? From point to point, how far down? 4. Okay, so -4 because we're going down 4. And then how far over? What was it? 5. Yeah.
Is B -2?
So down 4 over 5. B is -2. Yeah. So the slope is -4/5. The y-intercept is -2 because it crosses the y-axis 2 below the middle of the graph. That would be -2. So what's our answer? Somebody go and tell me the answer for this one.
Y equals
Y equals.
Hang on, Vicky had it.
-4.
Or was that Serenity?
-4, 5,
Yeah. There you go. Y equals -4/5 x minus 2. Awesome. So you're gonna answer 3 and 4 on your own. Take a couple minutes on that. And then we'll take a look at standard form. And then we are going to compare 2 different equations to figure out if they're parallel, perpendicular, or neither, just like we did yesterday. Yeah, I got a whole box of them. Yeah.
You're down that.
All right, let's take a look. So problem number 3, our slope for number 3, eyes back up here. Slope for number 3 is -1/3 because we're going down 1 over 3. The y-intercept is 0 because it's right in the middle of the graph. So we're going to write y equals -1/3 x. If you wrote y equals -1/3 x plus 0, that's fine too. But if you have the number 0, you don't technically have to write the number 0 because it's 0. So -1/3 x is fine. -1/3 x plus 0 is also fine. It just takes less time to write -1/3 x. So that's why I wrote that. Questions on number 3? Cool. How about number 4? Anybody have an answer for that one? That is correct. However, 3 over 3 reduces to 1. So yeah, y equals 1x plus 4. Or because 1 times x is just the same as x, you could also just write y equals x plus 4. But yeah, 3 over 3 is correct. Just make sure it gets reduced. Cool. Nice job. So y equals x plus 4 or y equals 1x plus 4. So that's your quick reminder on writing slope-intercept based on a graph. Now we're going to be talking about standard form after this. So here we go. Standard form. This one was taught last year. However, it was used, listen up, standard form was used far less than slope-intercept form. So the form of this one is ax plus by equals c. And standard form is used a lot less with graphing. Slope-intercept form is used mostly with graphing. Standard form is used a lot with word problems, actually. Word problems and then systems of equations where you had to solve for x and for y. That's what standard form is mostly used for. And so when you're dealing with standard form, the reason why we don't use it very often for graphing is because standard form does not give you the slope. Standard form also does not give you the y-intercept. Standard form basically gives you no information about the graph itself, which is why it's not usually used for graphing. So what we are going to have to do is figure out the slope and the y-intercept given standard form by converting it into slope-intercept. That way we can look at a y equals mx plus b equation from an initial equation of ax plus by equals c. And just as a reminder here, the reason why A, B, and C are capitalized, please write those as capital letters for A, B, and C. X and Y are lowercase. A, B, and C are capital letters because they are integers, meaning they're positive or negative whole number values. Every standard form equation that you see will include whole number values with X and Y, whereas with slope-intercept, we got fractions all over the place. So standard form, you're not going to see fractions in. The X and Y still just mean X and Y, like on a graph, X, Y coordinates on a graph. And so what we need to do here is every single one of these to get into slope-intercept form, let's just write a little note off to the side. Solve, write this down, solve for Y, meaning get Y by itself. If you get Y by itself, the equation will be in slope-intercept form. So solve for Y. Once you have Y by itself, you can check out what the slope and the y-intercept of the equation are. Okay, so with number 7, here we go. If we wanted to get y by itself, what would we have to do? Subtract x from both sides, yeah. Because right now, x and y are being added together. We want to get y by itself. The thing that is keeping y not by itself is the fact that x is being added onto it. So to get rid of that, we'll just subtract x from both sides. And if we subtract x from both sides, it'll cancel from the left.
5.
On the left side, we'll have y equals. However, hang on. If this was just a -1, we would write 5. However, this is an x. This is not an x. So something with an x and something without an x can't be put together because they're not like terms. So what we're going to do is just write -x plus 6. They have to stay separate.
Remember,
Yeah, that is slope-intercept form, because we got y by itself. So this was only one step to go from standard to slope-intercept. A couple of quick questions for you. What number would be next to x if a number was written?
1.
Yeah, it'd be -1, right? So now, if you look here, we have y equals mx plus b. It's in the same form as slope-intercept was up top. So side question, what does m equal?
Slope.
What number does m equal? -1, yeah. M does equal slope. The number for this one would be -1, because here the -1 is taking the place of the m. What would b be equal to? 6, yeah, so b equals 6. So we convert to slope-intercept, and we know that the slope of that line is -1 and that the y-intercept is +6. So we can do the same thing that we did with the equations above with these ones down here. We just have to get them into slope-intercept form first. Let's do a few more and then we'll take a look at the back. Problem number 8. We need to get y by itself. What's the first thing we need to do? This is going to be a 2-step one. So number 8, what's the first thing we need to do to try to get y by itself? Yeah, get rid of that 5x. Basically, get rid of the term with x first by adding it or subtracting it, whether it's positive or negative to begin with. These are all positive on this page to begin with. So basically, subtract the term with x first. So -5x minus 5x. When you subtract 5x from both sides, that'll give you 2y on the left equals -5x minus 2 on the right. We can't put those together. And there's one more thing that has to happen on this one, because y isn't quite by itself. It's still being multiplied by 2. So what do we have to do to get y by itself? Divide by 2. And here's a reminder for you. When you divide both sides by 2, you have to divide everything on both sides by 2. So the -5x gets divided by 2 and the -2 gets divided by 2. Everything gets divided by 2. So on the left, the 2's cancel out. And on the right, so we're going to get y equals. And this is where I don't want you to use decimals. Don't use decimals here. I think Rafi asked this yesterday, right? With decimals and slope.
Maybe two.
I did.
I think so. Somebody asked me.
Oh, yeah, I did.
Yeah. Somebody, I was gonna say, I think you asked me about decimals and slope yesterday. Don't write the slope as a decimal. So whatever number is next to X, if it doesn't divide evenly, which this one doesn't, it's negative 2.5, just leave it as a fraction. Leave it as negative 5/2. So we're gonna write Y equals negative 5/2X. And then negative 2 divided by 2 is negative 1, so that'll be -1. And so that would be the answer for slope-intercept form on number 8. The slope of this one,
Okay, where did one come
the one, negative 2 divided by 2 would be -1, because we have to divide everything by that number. So the slope on this one, M would equal negative 5/2. And the B value, the y-intercept, would be -1. So we can pick out the slope and the y-intercept once we get it into slope-intercept form. We'll do a couple more together, 9 and 10 together, and then I want you to try 11 and 12 on your own after that. Are there any questions about 7 or 8 before we look at 9 and 10? All right. So by the way, at most, you will have 2 steps to get y by itself. At a minimum, it'll only take 1 step to get y by itself, but you're never going to have to do more than 2 steps of algebra to get y by itself on these problems. All right, number 9, here we go. What are we going to do first on number 9? Subtract the 2x, yeah. Always get rid of the term with x first from the left, and so this means subtract it. The 4, by the way, over here on the left has a negative in front of it, so we need to keep that negative there. So this will be negative 4y equals negative 2x, and that is a positive 28 on the right, so we're going to write plus 28. What's our next step?
Right.
By -4.
Everything gets divided by -4. Good.
We didn't think about that way.
All right, now we got y on the left, which is what we want, equals, what is -2 over -4 reduced to?
Decimal.
1/2.
Positive 1/2. Good, positive 1/2. And by the way, if you're unsure about how the fractions reduce, just type it into the calculator as a fraction. -2 over -4. There it is, positive 1/2. You can just type it directly in, it'll give you the reduced fraction. 28 divided by -4 is -7, so we're going to write y equals 1/2 x minus 7. That is the slope-intercept equation for number 9.
Good morning. We are going to be doing vision screening this morning with the Lions Club members in the auditorium. We're going to call down students by your last name, and please report to the auditorium. This is optional. You do not have to participate in this, but if you would like your eyes checked to see if you need glasses, you can certainly participate. We're going to start out with freshmen. Last names A through L. If you're a freshman, your last name's A through L, and you want to have your vision checked, please go to the auditorium at this time.
So if you want a free vision check today, head on down to the auditorium. I think vision checks are usually, like if you pay for one, they're like $100 or something like that. So getting that for free, it's a good deal.
Oh, vision.
All right. Yeah, vision check. All right, so let's see. Slope on this one, 1/2, y-intercept, -7. All right, let's do number 10 together, and then I'm going to have you work on 11 and 12 on your own, and then we'll take a look at the back and wrap this up. So number 10, what do we do first? Subtract 3x. There we go. -3x minus 3x. This is a negative y. And just as a reminder here, I want everybody listening, please. Just as a reminder on a problem like number 10, a negative y is the same as a -1y, and I'm going to write the 1 there. -1y or -1y equals -3x. That was a positive 5, so we're going to write plus 5. The reason why I put the 1 there, the reason why the 1 is there is because it lets me know I still have to divide both sides in order to get y by itself. If there's just a negative there, sometimes people forget that you need to divide. But a negative by itself is the same as a -1. So I write the -1 just to make it more obvious that we still need to divide both sides by -1. And if you divide by -1, the number just turns into its opposite. It's like multiplying by -1. So we get y equals 3x minus 5. Which means we have a slope of 3, m equals 3. And we have a y-intercept of -5, b equals -5. All right, I want you to try 11 and 12 on your own. Take a couple minutes for those. And then we'll flip it over and talk about parallel, perpendicular, and neither, just like we did yesterday. And a reminder on the calculators, if you divide on your calculator and you get a decimal, if you divide on your calculator and you get a decimal, just push the button above enter, the little left-right arrow button above enter, and that'll turn it into a fraction. We definitely want the slopes as fractions.
Next five off.
All right. What's our slope intercept for number 11? The slope intercept equation, what is it for number 11? So the y equals blah, 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 blah.
Minus 2.
2/3?
We're on 11.
Yeah, number 11.
That's 3.
I got -3/4.
Well, it's 3/4, never mind.
Bruh.
If we had if it was 6/9, we'd have 2/3, but 6/8 is going to be 3/4. So -3/4 x and then -2. So our slope should be -3/4 and our y-intercept should be -2. All right. By the way, on your calculators real quick, take a look. Listen up. On your calculators, if you type in -6 divided by 8, it's going to give you an answer of -0.75. If you push the button right above enter after you do the division, it'll give you the fraction slope of -3/4. So you're welcome just to go ahead and use your calculator for this. If you want to do it by hand using mental math, feel free to do that. Sometimes it's a good idea to double check on the calculator just in case. So how about number 12? Catherine, what'd you get? So I like the 0, I like the 1/4. However, I think it's positive 1/4. Yeah. Because when you subtract the x from both sides, you get a -1 in front of the x, and then when you divide it by another negative, it turns it back to positive. So yeah. If you want to do the -0 or the +0 at the end, you're welcome to do that. I just left it blank because the 0 kind of went away there. If you kept the 0, that is totally fine. I would not mark you down for that on the test or quiz. You can keep the 0. Most of the time, though, if the number is 0, you won't see the 0 written, which is why I'm not writing it here, but you are welcome to keep the 0. The slope is 1/4, the y-intercept is 0. Excellent. Any questions on 11 or 12? Cool. Flip it over. Oh yeah, real quick, I almost forgot. We got to talk about horizontal and vertical lines. But the good thing is we've already talked about horizontal and vertical lines this year when we were talking about reflections. Remember when we were talking about reflections over the line, y equals 3 or x equals -2, things like that? That's what horizontal and vertical lines are. So this particular line here is a vertical line. Yeah?
Yeah.
What is the x value of every single point on that line? If I were to put a dot right here, What's the x value there? -1. Yeah, the x value is -1 because it's left 1. If I put a dot here, what is the x value of that point? -1. What if I put a dot down here? Yeah, it's the x is -1 again. So yeah, you can put the dots on there, that's fine. And every single one of those points, has an x value of -1. And if every x value is exactly the same, the entire line can be defined by just the x value. Meaning, the equation of this line is x equals -1. As long as the x value is exactly the same for every single point, the entire line can be written based on just the x value, x equals -1. Anytime you have an x equals, that is a vertical line, which means the slope is undefined. Likewise, anytime you have a horizontal line, what is the y value of this point right here? 3, okay? What is the y value of this point? 3. What's the y value of that point? 3. Every single y value on a horizontal line is the same. So the equation for this one is y equals 3. How far up is this line from the x-axis? Yeah, so it's up 3, so the y value has to be 3 for every single point. So every single horizontal line is just y equals some number. Every single vertical line is just x equals some number. And that's because every x value on a vertical line is the same x value. Every single y value on a horizontal line is the same y value. All right, now we are going to be comparing equations. And we are going to determine whether the equations are parallel, perpendicular, or neither. Now, yesterday we talked about what makes lines parallel, perpendicular, or neither. What makes lines parallel? What makes lines perpendicular? Opposite reciprocal what? What part of the line? So you said parallel lines have same slope, right? Opposite reciprocal slope, right? So what is the only part of the line that we care about?
Why?
The slope, yeah. The only part of the line that we care about for these problems is the slope. We only need the slope. So I'm going to write that above here. We only, write it in capital letters. We only need the slope. If you can find the slope, you can answer every single one of these questions. And it turns into exactly what we did yesterday. Once you have the slope of each line, you can determine if it's exactly the same, parallel, opposite reciprocal, perpendicular, or neither. All right. So let's take a look at the first one. What's the slope of the first line here? 5. What's the slope of the second line? 5. So this one here and this one here. And the reason why we know that those are the slopes is because both equations are in slope-intercept form. They're both in y equals mx plus b. So if that slope is 5 and that slope is 5, what does that tell us about the lines? Parallel. They're the same. Yeah, same means parallel. There we go. Yeah. Oh, you need a pencil? Do you need wait, or do you need an eraser? Do you want an eraser? Okay, I got plenty of those. All right. Well, let's toss it back, see if I can get this to you. You ready? Here we go. All right. 2's parallel.
Wait, is number 1 parallel?
1's parallel. What about number 2? 2's perpendicular, yeah. So right here, first one on problem number 2, m equals -3/2. The second slope, m equals 2/3.
Parallel.
Is that the exact same number though? No.
Okay, it's time for the next group of freshmen. If your last name starts with the letters M through Z and you've not had your vision checked and you would like to have it checked, remember this is optional. You can go to the auditorium at this time and have your vision checked.
Cool. So number 2, 2's perpendicular because we have a positive and a negative. Number 2, we have a positive and a negative, and they're flipped over versions of the same fraction. Opposite reciprocal slopes for number 2, perpendicular lines. All right. So we got 1 and 2. Now, number 3 What's different about number 3 than both 1 and 2? They're both in standard form, yeah.
Yeah.
So we have to do on number 3 to both equations what we did on the equations from problems 7 through 12. So on number 3, we have to first subtract x from both sides. So we got a little bit of algebra that needs to happen here. If y is not by itself, we do not know what the slope is yet. We have to get y by itself, which is why we did what we did on the front side. So we're going to get 2y equals negative 1x. I'm going to put a 1 in front of that x, and then plus 2. I'm going to make myself a little dividing line here as well. And then we have to divide everything by 2 to get y by itself. And we get y equals negative 1/2 x plus 1. The only thing that we need, though, from this line is the slope. We don't really care about what the y-intercept is. We need the slope. It's negative 1/2.
He said go slow.
Okay, I'll leave that there for a second.
Thank you.
Ouch. All right. So that's the first equation. Good?
Yeah.
Okay. For the second equation, we got to start by subtracting 6x from both sides. And then on the left, we're going to have negative 3y equals negative 6x plus 21. Once we move the x over, we're going to divide everything by the number with y, which is negative 3. And we're going to get y equals negative 6 divided by negative 3 is positive 2. So that'll be 2x. And then 21 divided by 3 is negative 7. But again, we only care about the slope here. It's positive 2. Those are perpendicular. Opposite reciprocal slopes mean perpendicular lines. We got a positive and a negative, and they are flipped over versions of the same fraction.
Wait, but it's.
What's that? Oh, without the 1? Any whole number can have a 1 underneath it. Yeah. So 1/2 and 2 are reciprocal. 1/9 and 9 are reciprocals. Okay. I want you to do 8, 9, and 10 on your own. So skip 4 and 5. Do 8, 9, and 10. Try those 3 on your own real quick. What's that? So if it's a y equals, an x equals. Okay. Eight, 9, and 10.
Yeah, I know.
No, you can't actually because they're different types of line. What kind of a line is that? Yeah. What kind of a line is that? What's the relationship between horizontal and vertical? There you go. Those are both equal. No. Oh, nice. Yeah, those ones actually end up being the easiest ones. Yeah. 3, yeah. By the way, once you know what to do with 11 and 12, those ones actually become the easiest because there's no math involved for 11 and 12. If you want to try them, you can. We'll do them together, but if you want to try 11 and 12, you're welcome to give those a go too.
I can use this one.
You got it?
Yeah.
All right.
Wait, the first one on top, right?
Hmm?
The first number.
What do you mean?
Wait, what are you talking about?
I was talking about 11 and 12.
Yeah.
There's no math involved there, no. I'll show you in a minute. What are we simplifying, Vicky? What are you simplifying? So negative 4. So type in negative 4 divided by 6. And hit enter. It'll give you a decimal, right? Now push the button above enter. The little left right arrow button. There you go. Nice job, Serenity.
That day, we were joking about the first thing now.
There's number 8. Eight should be perpendicular. 9 should actually be a little bit easier than 8. Why is 9 just a little bit easier than 8? Yeah, one of them is already in slope intercept. So you only have to convert one of them on number 9 because that first one, negative 1/4 is the slope because it's already in slope intercept. We're about to find out. Let's see. I actually don't remember, so let's see. Yeah, it is. Oh, 10 is also a little bit easier than number 8. And then looks like 10. 10 is also parallel. The 8 is perpendicular, 9 is parallel, 10 is parallel. Any questions on 8, 9, or 10? So we'll take a look at 11 and 12 real quick, and then we'll be done. 11 and 12 will be the fastest ones, I promise. All right. Are there any questions on 8, 9, or 10? All right, go ahead and get those written down. Give you about another minute to get those written down. If you have questions, let me know. We'll finish up very quickly with 11 and 12. Super fast for 11 and 12.
They're
Which ones? 11? Good. Okay. We'll find out. All right. Anybody need more time on 8, 9, or 10? Okay, I don't see hands up. Let's look at 11 then. So, Rob, you're saying number 11 are perpendicular? Why?
Why 7 we do 3 no 5.
Yeah, if you look at the top of the page real quick, a y equals -7 would be similar to a y equals 3, which means horizontal. So number 11 The first one, y equals -7, is a horizontal line. The other one is vertical. X equals 2 looks like the first one at the top of the page where it was an x equals a number. That's a vertical line. We talked about yesterday. No, it's not. Oh, wait, 12 you said. Okay. 11, though, any horizontal line and any vertical line have to be what?
Perpendicular.
Perpendicular. There you go. So the answer for number 11 is perpendicular. If you have an x equals just a number and you have a y equals just a number, those will be perpendicular lines because one's horizontal and the other is vertical. However, on number 12, x equals and then another x equals, they're both vertical lines, which means they're what?
Parallel.
Parallel, yeah.
Okay, we're ready for our next group of students. This is for the optional vision screening in the auditorium. If you're a sophomore, last names begin with the letters A through L, A
There you
through
go.
L, please go to the auditorium.
Cool. So that's what we got for today's notes. I'm going to go ahead and hand out your assignments. By the way, before I forget, listen up. This is our second to last lesson of the unit. Whoa. So on Friday, everybody listening? On Friday, we will have a quiz over the lessons we've done this week. So yesterday's lesson, the one we just did, and then the one we're gonna do tomorrow. We'll have a quiz on those 3 things on Friday and be open notes. Next week, when we come back on Monday, because tomorrow is the very last lesson of the unit, when we come back on Monday, we're gonna start our unit review. So that's gonna include the stuff that we've talked about in the first half of the unit. We're gonna spend at least 2 days on the review, especially looking at the first part of the unit because you had a few lessons from not me last week on those things. So we'll definitely take some time reviewing, and then you can expect the unit test around next Wednesday
Wait, so like from the beginning?
of the unit. Yeah, so like the transversals and parallel lines and like corresponding angles and alternate interior and all that, that'll be on the test. Yeah. All right, so here comes your assignment. We got a few minutes left for this on Wednesday. We don't have a whole lot of time to get started on these. You want to get about
I'm not.
very consistent color palette. Yeah. Yesterday? Yeah, come on.
Hey, you guys-